Lesson 314, Pie Charts and Multiplying and Dividing Fractions. In this unit, of course, we focused on the skills and steps of multiplying and dividing fractions. And in this lesson, we're going to look at some scenarios where we're applying those skills to data that's being represented in the form of pie charts. Let's take a look at this example here. We've got two pie charts. And at the top, the statement says that these graphs show the results of the school board elections. So the pie chart on the left is focused on the data or the votes from voters that are between the ages of 18 and 35, while the pie chart on the right is showing the data or the votes of those voters who are 35 years or older. And you can see just from a quick glance that the data is quite different. This candidate, Johnson, was very popular with the younger voters, receiving half the votes, while the older voters, 35 years and up, seemed to favor Smith, who got half the votes. So using the data here, now let's move on to the questions. And question one, started to take some notes here. As you can see, question one states, voters 18 to 35 cast 27 votes for Choi. Let's take a look at that. So we're dealing with this pie chart for question one, voters 18 to 35. And 3/10 of those voters we see voted for Choi. What this is telling us is that 3/10 of these voters means 27 votes. Now, how many votes were cast altogether in this age group? How many voters between the ages of 18 and 35 were there in this election? Well, there's a few ways that we could set this up and solve it. I'm going to talk you through at least the strategy that I feel is clearest to explain. And that's as follows. If 3/10 of the voters in this age group represents 27 votes, well, then I can figure out 1/10. Simply divide both sides, the left side and the right side of the equal sign, by 3. 3/10 of the total votes of this age group is 27 votes. So 1/10 of this whole is 9 votes. Right, now you might be asking, well, who cares? We're not trying to figure out 1/10, we're trying to figure out the whole, how many votes altogether for this age group. Well, look, if 1/10 of the whole is 9 votes, what's the whole have to be? Multiply the left and the right side by 10. 1/10 times 10 represents the whole age group, the results of the whole age group, or 9 votes times 10 equals 90. 90 votes. Let me rewind the tape and just talk through that again. We are told that 3/10 of this whole represents 27 votes. Using that, I can then divide both of these values by 3 to show that 1/10 must represent 9 votes. And then I can multiply both sides of this by 10 to show that the whole represents 90 votes. Question 2. There were 72 voters in the 35 and older age group. Okay, it's shown by this pie chart. How many of them voted for Johnson? Okay, so if the whole represents 72 voters, I'm trying to figure out what's 3/18 of 72. So 3/18 of 72 is equal to, think what operation? Multiplying. 3/18 times 72. When we multiply a fraction by a whole number, remember we're going to write the whole number, represent the whole number as itself over 1. Before we proceed, look for an opportunity to use cross-canceling. Thinking about your multiplication facts, can you tell me the greatest common factor that 18 and 72 both share? Think, think, think. If you said 3 or 6 or 9, you're on the right track because all of those factors would go into 18 and 72. But the greatest common factor that 18 and 72 both share is actually 18. So, how many times does 18 go into itself? Once. How many times does 18 go into 72? In this case, 4. Now, multiply across the top, 3 times 4. Multiply across the bottom, 1 times 1. And get a final answer of 12 voters. The next set of questions asks us to suppose that we were interested in the combined results of the two age groups. Question 3, what fraction of the voters chose Johnson? Okay. Well, there's a few ways, again, that we can approach this and set it up and solve it. To me, the way that makes the most sense would be to figure out the total number of voters in this group and this group, and then figure out how many votes Johnson got altogether. And we can then show that as a fraction. So it's not as simple as just taking this fraction and adding this fraction. And I'll tell you why. Because we can show in a moment that the number of voters in this age group was not the same as the number of voters in this age group. So it's not an apples to apples sort of deal. So let's do this. Let's figure out how many voters there were altogether. In question 1, we actually calculated that. We calculated that the younger voters, there was 90 votes from this group. And then the older voters, it tells us in question 2, there were 72 voters. So using that information, total number of voters, combining both age groups, is simply 90 younger plus 72 older. Can you do that as mental math? 162 total voters. Now, how many voted for Johnson? All right. Well, of the younger voters, half of them voted for Johnson. So what's half of 90? 45. And then of the older ones, 3/18 voted for Johnson. What's 3/18 of 72? Well, we're going to have to work that out as a side calculation. 3/18 multiplied by 72. Actually, we already solved that, didn't we? We solved that in question 2. Johnson got 12 votes from the older group. So bring it on home. 45 from the younger crowd plus 12 votes from the older crowd means Johnson got 57 altogether. So 57 out of 162. Yikes. And I know I'm running out of space here to show that. But this is the fractional amount of voters that chose Johnson, 57 out of 162. Now we can simplify that. The greatest common factor shared by 57 and 162, I believe, is going to be 3. So let's divide the top by 3, and we'll get 19. And let's divide the bottom by 3, and we will get 54. Now, that's our final answer. Okay. What fraction of the voters chose Smith? Well, let's look at how Smith did. With the young voters, there were 90 of them altogether. Smith got 1/5 of the vote. So we got to calculate what 1/5 of 90 is. And then of the older voters, Smith got half the vote. So it said there were 72 voters in the older crowd. I've set it up like this: 1/5 multiplied by 90 plus 1/2 multiplied by 72. When you work this out, 1/5 multiplied by 90 ends up being 18. 1/2 multiplied by 72 ends up being 36. So Smith got 54 votes, 54 out of the 162 altogether. Which means let's see here. We've got to simplify this. Boy, these fractions are kind of bigger number crunching than I had expected. But I know we can divide both of these numbers by 2 to start off with. I don't know if 2 is the greatest common factor, but let's give it a whirl. 54 divided by 2, that gets us 27. Okay. 162 divided by 2 gets us 81. Oh, we can go further. I can divide both of these by 9. 27 divided by 9 is 3. 81 divided by 9, oh, is 9. I can keep reducing this. What's 3/9 in simplest form? Dun, dun, dun. 1/3 of the total voters. All right. What fraction of the voters chose Choi? Choi got 3/10 of the young crowd. So we have to calculate 3/10 of 90, which I'm just going to do as mental math right here using cross-canceling. And actually it tells us in the first problem that Choi got 27 votes. Now figure out the votes that Choi got from the older crowd. 1/3 of 72, which is, let's see here, 24. Add these two up. I get 51 votes out of 162. So 51 over 162. And I know that 3 can go into the top and bottom. I know I can simplify it that way. 51 divided by 3 ends up being 17. 162 divided by 3 ends up being 54. 17 over 54.